Right. Hi again. My name is Vladimir. I'm from OnSec Lab company, and I want to get this report together with my friend Alexander, but his visa was rejected. It's not so good, but not so critical, of course. I want to speak about server-side request forgery attacks, pawns using it attacks, and something about new techniques, and something about real stories from reward programs using server-side request forgery attacks. So it's a monster. Something about us. I'm and Alexander, founders of a small web application security company in Russia since 9 years, and I'm a web application security expert and also a bug hunter, and Alexander is a network security expert and also a Debian and maintainer of packages. Our company have an English blog, you can follow us, and also by Twitter, and we are awarded by something reward programs such as Google, Yandex, and another reward programs. Also, we want to create yet another web application firewall solution. I think it's a short intro, and that's all. And what about server-side request forgery? Server-side request forgery attacks first described in 8 years by Daryl Hayland at the ShmooCon conference, and then reincarnated by me during Yandex month of security bugs of 11 years. It's the first implementation of server-side request forgery attacks using XML external entity vulnerability. And then in the next year, in the 12th year, server-side request forgery attacks by EAP scan guys, Alexander Polyakov and Dmitry Chistuhin, successfully exploited SAP system, of course using new techniques of Gopher protocol schema, which provide us to make partially any TCP packet inside the intranet. And then this kind of attacks were already discovered by Rias Velika in end of 12th year, and then exploited Memcached and fast CGI by us again in Zero Nights conference. And at the final of year, our techniques, server-side request forgery, was rewarded by White Hat Security as second place in top 10 web hacking techniques of 12th year. And also got a CV number of 918. Something about SSRF again. What is server-side request forgery from attacker and from a defender? Server-side request forgery by CV is not described incorrectly because you can see in definition of CV that server-side request forgery attacks is web server ability to use an URL from user parameters and use this as a source of any packets. But it's not so correct terms, correct definition, because not only web servers are vulnerable to server-side request forgery and not only using URLs. You can see a simple example of PHP code which is vulnerable to server-side request forgery without URLs in user parameters. I can also use socket injection, such as CRLF injection to socket to forge a request. You can, in this case, change a destination address, destination port, but you can change a packet to host and get a server-side request forgery, of course, again, because it's not a logic in a web application. It's a simple injection, and the server-side request forgery, of course, also. So, before we start, server-side request forgery attacks, described it some slides ago, used to bypass host-based authorization. It's a previously implementation of this kind of attacks and exploits. Also used for bypass firewalls and abusing trust relationships, and maybe use it for other implementations, other kinds of exploitations. But is there any other ways to do the same? Is there any other ways to bypass firewalls, to bypass, to abuse a host-based house, to forge packets from a host which you want? Obviously, it's not one method, and a long time ago, in the early 19th, described simple techniques called spoofing. I think you know these techniques in details. So, hello from early 19th techniques which works nowadays. The main idea of UDP spoofing based on packets forwards between network interfaces, as this feature enabled by default in Debian and Red Hat Linuxes and the other operation systems. And the UDP packet can be easily sent from a internet by classic spoofing attack. In many hosters, UDP are not allowed from a gray network, from internet, but it's very security hosters. In this case, you can also exploit UDP by simple buying a host in this hosting to abuse other customers of this hosting. It's not a great. You can exploit your SNMP, memcached, and other UDP plus host-based out servers. SNMP not so host-based, but you can exploit this using public key. It's a very common situation. To protect from this, use sysctl net.ip version 4.conf, your interface name, and RP filter from sysctl. It's enabled by default and obviously working from early 19th to nowadays. So, advanced UDP spoofing exploitation, which we use it during our security audits and other research work, based on exploitation services as a server-side request forgery. It's also known, also called reflection attacks, and well known since 19th. But now you can exploit this to bypass in firewalls in deep network. I think at next slide I try to describe this more correctly. Simple spoofing attacks, reflection attacks, where service response used as a request to another service. You spoof initial packet and described in this packet source address to another host which you want to exploit. And the server get your request and generate a response to your source address, spoofed address, and exploit something in a deep network through firewalls, if firewalls have a rule to do this, of course. And spoofed packet attackers set source IP port from a victim, and also in web application security area, memcached, it's my favorite service because use it in great number of our customers and have a host-based authorization in most cases. And of course, echo service, if you can find echo service in modern infrastructures, network infrastructures and service, echo service is ideal for this purpose because echo service generate a response as the same as the request. It's not so easy. So it's a simple reflection attack, and also may be known, may called as a server-side request forgery attacks. This is a monster, and the monster want to exploit host B through firewall. Monster have no ability to send packets directly to host B because firewall restrict this packet. Monster can use techniques from early 19th. Must spoof a packet, UDP packet to host A, of course, UDP packet. At the next slide, I want to speak about TCP also. It's only just about UDP. Monster spoof a packet and to host A and set source address and destination address to host B. Then host A generate an answer to response to this packet and send it to host B, of course, because it's it's a previously fact. So in exploitation memcached, we research a ping-pong effect of this exploitation. Simple way, of course, reflection attacks depends on your protocol, on your response formats, and to do reflection attacks, you must find a service which the correlation between responses and requests, and the response request response packet must be valid as a request to the another service. It's a main idea of reflection attacks, if you want. At first point, Monster spoofed a packet to set K in memcache to host A, and K have a value stats, as you can see at this slide. Then Monster again spoofed a new packet, and packet data get this K. K have name K, key, and then spoof this packet and set source of this packet of host B. Send that packet to host A, memcached of course, and host A generate response to host B with the value of stats. Neat trick of this that host B parse this request as two independent commands. First command is value key, it's not correct commands, but parsing continue and stats commands executed at host B. It's main idea of this effect. But they're also not so good because after this injection, host A and host B established infinite session and by exchanging error commands. And this is really infinite cycle. And but anyway, Monster injected commands into host B, and this is working attacks. So in this slide, you can see TCP dump of these attacks, and the red color. Red color marked initial request, and the green color marked main idea of this attack, and it's injection. And then you can see also a red color at the bottom of slide, infinite cycle of memcached exchange. So, and you can see also a simple command to do this. And at the top of slide, and by red color marked injection data, and green color it's a UDP header which memcached understand. So, hello from 12th year. In the 12th year, TCP fast open declaration been implemented in the Linux kernel since 3.6. TCP fast open provide us to send SYN plus data packets in one packet, and it's look like a best way to spoofing TCP packets, but not so good because SYN plus data also require a special cookie crafted by server. It's the initial classic TCP connection and sent to a client to create a new connection by using TCP fast open. It's not so good to attacker because in the Linux implementation, the cookie generates by advanced encryption standard, RegionDL, as you know, using a key and the client IP. Key have 60 bytes length, and it's not so bootable in real time. But we still we're still waiting for other TFO implementations. An example, Microsoft can do something vulnerable on other vendors. So, TCP Fast Open also have by design security limitations, not so bugs, but only limitations. First limitation is one cookie for all clients ports, and if you know a cookie to this client, you can forge any packets to any ports without any restriction by server. Server validates only client IP. And the second limitation is one secret key for a server for all clients. If you know a server key, you can generate cookie for all clients, but it's not possible at this moment to know this server key. Yeah. So, another vector of attacks, network attacks in general, with the same of server-side request forgery effect, is using IP version 6. Its implementation widely used at this moment, and can be used simple to bypass filters such as regular expressions, which restrict localhost domain name and IP version 4, 126.0.0.1 IP address by using IP version 6 local address. Also, can be exploited link local firewalls bypass and exploiting auto configurations IP version 6. In details at this slide. First, TCP Fast Open concept attacks used this trick, that one cookie for client and any ports. In the clouds, it's only a concept, only for my mind experiment, not in real cases. Can be exploited while any manager in the cloud change IP address of your host. And if monster have access to host A with the IP address A, he can generate a TCP Fast Open cookie for this IP address, and at the moment in the future when cloud manager change IP addresses, monster at the new IP addresses can exploit a spoof packet for his previous IP address. It is obviously, and I think it's not for another comments. It's only TCP Fast Open by design limitation, and I think it must be described in RFC. So, IP version 6 link local addresses. Our another trick while our security audits and exploitation of our clients, based on neat trick about link local addresses, because many system admins forget about these addresses and configure firewalls only by using currently IP version 4 addresses or IP version 6, but not link local addresses. And host A with a monster can bypass firewalls using link local addresses of host B. Monster can try to sniff broadcasters to determine addresses, link local addresses of host B, or but of course it's require root privileges, or can use AP link local AP version 6 by Mac calculator, but not in the Microsoft network, because Microsoft have no algo to generate AP version 6 link local addresses by Macs, only from randoms. So, yet another implementation of IP version 6 to provide us to do the same as SSRF, server-side request forgery attacks, is using route advertisement. Again, require a monster own host in a same network segment as a victim host, and also require root privileges, because there are no ways to forge route advertisement packet without root privileges. wants to have a possibility to do this and create a RA packet to host B with new new IP version 6 addresses. Host B, by default, any numbers of operation systems such as Debian and Red Hat again have enabled a feature to IP version 6 configuration by router advertisement. But I try again. This required that host A and host B exists in one network segment, not from the internet, only in one network segment. And then, of course, host B receive array packet and add the new IP version 6 address to his interface. And now there are no ways to block this address because it's new address, and the firewalls based on blacklists will be bypassed in this case. So, what's the conclusion? Host-based house must die, of course. There's no way to protect your host-based house host using firewalls and others. That's not so good idea to strict network firewalls to protect your services. Really great idea to implement authorization in this host, and this is really work. So now we start. Now I can start talk about server-side request forgery protocols, schemas, and try to talk to you about these schemas. And also want to speak about server-side request forgery, not only in web applications. It's not a good idea to describe server-side request forgery attacks as a threat of web applications. Not so correct, because as we show a few slides ago, server-side request forgery attacks can be also used, exploited by simple reflection spoofing or something in other ways, not only in web applications. So, protocol schemas. Different protocols provides to attacker different actions, of course, because protocols have a himself packet format, and any implementation of this this formatted packet sending. Not only sending data, but also can leak data. If you have a server-side request forgery in a packet with data which you want to sniff, you can sniff this simple by redirect this packet to other host or forge destination address or something else trick, describe it in server-side request forgery Bible cheat sheet. It's a chapter of exploitation original request data sniffing. Yeah? It's not so new, but it's so new. Protocol schema telnet, I think really rare implemented, but exists in curl, exists in Java, in the previous version of Java, of course, before global fix of protocol schemas, and .NET also. Telnet protocol schema provide attacker to read data from std_in. From std_in of process, which can be SSRF'd by attacker. It may provide to read all clients' data in case of common gateway interface CGI, but not so common in this case in nowadays, and so bad that in mod PHP ways or fast CGI, std_in is std out on zero device. But common gateway interface is still for enterprise web apps, and also we have a .NET implementation, Java implementation, which depends on application server and application logic. It's a really nice idea to work with std_in, std out process using server-side request forgery attacks. And not only packets, not only network exploitation, just only system process data. It's really must be understood by everything who want to exploit server-side request forgery attacks. It's really possible and really useful in many cases. So, I want to ask you which server is the most secure in your environment, in your network environment. I think it's a VPN server because VPN server basically is front-end, front-end, and have a unrestricted access from internet, and you must configure your VPN server with the maximum security restrictions, with the maximal security privileges, and followed by security updates at this server. So you can answer that any other security socket layer service, the most secure in your network environment. It's also obviously because I think that security socket layer is the most famous security guard for any network services, such as Jailbird, such as VPN, such as HTTP, called HTTPS, of course, and other. But it's not so correct because, because you have way to SSRF public infrastructure. It's really great, and you have two cats. It's a good cat, it's not so good cat. Client can create a self-signed certificate and include a server-side request forgery attacks vector inside a serial file in the certificate, inside the online certificate status protocol URL file, inside the timestamp protocol, and maybe other extended attributes of certificate, and then send this certificate as a client certificate to public infrastructure to SSL validator. Now, SSL validator have two ways and maybe three ways to validate the certificate. I think I described this. This exploitation, of course, depends on service SSL validator logic. SSL validation logic can check certificate trust relationships before validation of certificate status or not. It depends only by implementation of SSL and not described in RFC, something another documents and instructions. It's only by developer choose, system administration choose. External resources, as I said before, can be defined in certificates such as serial file, or CSP file, TSP file, URLs, and maybe others. Depends on current implementation of SSL and PKI, of course. So, different implementation of PKI by green color not vulnerable and by red color vulnerable. Simple way, Nginx way to check serial CSP, not from a certificate, but only from a config. And there's no way to exploit Nginx using this attack vector because you can't change Nginx config from internet. Also a good way to check trust relationships, check signature of CA, intermediate CA, and user CA, user signature before checking certificate status. It's a good way. But also can be vulnerable in theory if you know a private key of CA. But if you know a private key of CA, I think server-side request forgery attacks, it's not needed for you. You can exploit anything without it. Bad ways to implementation of server-side request forgery. SSL to provide server-side request forgery is checking certificate status before trust relationship, such as CA and intermediate CA, and other is checking intermediate CA certificate status before trust relationship, because intermediate CA in CA also can be created by attacker with self-signed root CA. It's not so. Yeah, this slide you can see different block schemas of verify certificate algo. First column is any vendors ask me to don't disclose vendor's name, which vulnerable to this, and I think this vendor A. Vendor A implementation first column based on a simple check if user certificate is self-signed, certificate was rejected, and if not, certificate parsed and status certificate will be validated, and you can find a server-side request forgery attacks in this case. It's easy to understand because, as I said again, serial URL, OCSP URL, and timestamp protocol URL define it in a certificate, in self-signed certificate, and if you have a CA, such as self-signed CA, exploit work. And the second column is also vulnerable, ALGA. Parse certificate at the first stage, and the second stage is checking CA or intermediate CA, and then verify this CA status before trust relationship, before checking signature, before compare the CA with a trust key store. And again, attacker can issue a self-signed CA and define a serial and TSP and OCSP URLs in this CA or intermediate CA certificate. It's not so hard to attacker if you understand this. And then at the third column, you can see nice SSL implementations, which first validated trust relations and signage before certificate status validation. It's another vendor's implementation way of SSL checking and other. And I think that I have slide. Yeah, at the slide you can see main schema of these attacks. And Monster issue a certificate with serial CSP and TSP files, which reference it to internal host B and send this certificate to host A. It's maybe VPN server or other server which validated client certificate. And it's not so easy to use this in the wild because many servers, such as application servers, by default send to client file sent to client during SSL session, which I'm not want to check your certificate. But anyway, if you patched GNU, TLS, or other SSL library, you can anyway send a certificate to a server. And any servers, I think the must come number of all servers, all SSL servers, can pass this certificate and then start a validation process. And this way, Monster again exploited a host B, and in this case, memcached. I really love memcached. It's my bread. So, something about server-side request forgery practice. As I said again, I can disclose vendors to my ethical principles in public infrastructure attacks, but you can test this attack on your VPN servers, on your web servers, on your application servers, and other implementations of SSL, and I think it should work. Now something about our server-side request forgery practice. We try to participate in Yandex bug bounty system and the reward program and find something interesting. We exploited memcached in the Yandex intranet using server-side request forgery and discovered a few intranet services in the Yandex network, and also discovered main infrastructure bugs which accepted by Yandex team as critical, and also got a fun and skills, of course, because server-side request forgery attacks, it's something new for us and something new for community, I think. And we really try to shock Yandex security team. So, our results. 11 server-side request forgery bugs without classic ways to use XML external entity. 7 XXE plus server-side request forgery bugs, and much money. And average $716 per one bug. It's not so good and not so but not so critical because the maximum award system in Yandex currently is $100, $100. So nice server-side request forgery story using DNS service. Yandex as a Google have a webmaster service provides. In general, Yandex and Google have really really similar services. Webmaster service provides content receiving, but only from your hosts, your sites. And this validation process based on files and DNS records. It's not so good idea because verification by domain, but not by IP. And we create an attack vector to verify domain and then change a record to this domain inside the Yandex intranet to try receive content from intranet. I think it's obviously vector, but maybe it should work. You can see this slide. It's an interface of Webmaster, Yandex Webmaster tool, and you can see my domain at mine host, and you can see that my domain have a record to Yandex intranet, and I receive content which marked by red color at the bottom of slide. Easy and really hard because now I have access to Yandex intranet restricted only by firewalls, but I have no ways to validate firewalls rules. I have only tried to receive data from some hosts which I can what? I can use also intranet scan using SSRF. It's not so ethical for me, yes, because it's generate IDS alerts, and it's not by reward program, because reward program mean that you can also exploit front-end bugs, web application bugs, such as logic bypasses, accesses, and other server-side bugs also, but not mean exploitation of these bugs. I'm using Google to hack Yandex. It's not so not so hard to understand. To find hosts in intranet and nothing more. And exploitation of SSRF to retrieve sentence data is not so ethical for me, and I use this only for validate these attacks and receive not critical and not sentences data from intranet, but demonstrate that I have access to restricted by firewalls from internet hosts. So. In this slide, you can see a simple way to find config files in Google. Someone from Yandex team published a configuration file in Google in a forum, and Google indexed this file, and I find this using a simple command line. I think it's not a problem for attacker, and I think it's ethical. I couldn't use network scan and other black ways to exploitation of server-side request forgery, and can validate this kind of attack, can validate my server-side request forgery exploit. And this slide, you can see IP address, which showed at this slide. It's on the, and also a domain name and some configuration parameters, such as, I think, you know what you find in this configuration file. Not so easy way, but again, this is not classic server-side request forgery attack described in CVE, because there are no URL in general. We have static URL and only change a DNS record to intranet. But this attack works, and I received some data from intranet. So, I think that I saved your time to lunch, and now you can ask me any questions. Thank you. Yeah, right. I think I missed something. What? Andrew asked me what way to receive a data from host B in these attack techniques, because you can only forge a packet and you have no way to receive a memcached case. You have no way to get a data from memcached. I think
Q&A.
not so clearly, because my ethical principles. First, in case of memcached, there is no way to do this, as I know. But at this case, you can change a memcached server to other NoSQL server which used UDP. And in this case, you can use special commands in this NoSQL server, such as Redis and CouchDB and other servers. Sometimes in this logic you can find a command like ping, like connect to external data and other, and you must exploit this as a blind techniques. There is no way even using a timing. You have no ways to read data in memcached by this, but in real security audits, when we know an application and know something about memcached format, this way only for injection sessions. We can inject session with great privileges in memcached using this packet, and then check this session from a web host, from a front ends. It's not only one way, as I think, but in case of memcached, I think I have no ways to get data.
In your last example with the Yandex, you used the webmaster tool site, and by setting the A records to their internal IP, the webmaster tools would connect to their internal IP address. Why would their internal firewall allow this connection at all?
I think you must ask Yandex guys, which presented in this hall, about this.
It sounds to me like a poorly designed firewall on their end.
Really, I have no way to answer you.
Okay.
It's a black box for me, and I only try to do something cool things and check if it's work or not. I have no ways to validate many firewalls rules and other, because I have no access to these firewalls.
Any other questions from the floor? Yeah.
Thank you for a great talk. I have a question about UDP reflections that you mentioned earlier. Is there a way to do network reconnaissance to scan the network without knowing if the service is actually on that IP endpoint? Because here you must know the host B IP address and the fact that memcached runs there. And is it possible to do some reconnaissance with the reflection, or is it impossible?
Yeah, I think you must ask me about forge packets to loopback interface.
No. When you reflect packets, you never get any information about if the service was actually there. So do you have any means to find that out? I think you said that you have no ways to force memcached to ping you back for you to know. So the techniques that you did not disclose for other NoSQL databases should be applicable here to ping you back for you to know that the service is actually there. Yes, for network scans.
Yeah, I already talked about NoSQL databases which have ping back ways to attacks in this. But in memcached have a simple syntax of a commands, only jet commands and set commands and other simple commands such as version and states, and have no ways to create a pingback attacks. And maybe attack vector may be based on exchange data from a memcached B to memcached A, and maybe you can create an iterative attack vector and use these infinite loops to iterate data from memcached B, but it looks like hard to create this exploit, and I can't answer you now, but it looks like possible anyway. Yeah.
Mm-hmm. And the second question about the client certificates. You said that even if there is a plain HTTPS website which does not require the client certificate, you can modify your client to send the client certificate, and the server will still. Is it the common behavior, or can you disclose any information about that?
It's really commonly, and I'm shocked by that.
Okay. And the last question is about the URL schemas that are allowed in the certificate, the client certificates. Are there any powerful schemas such as Gopher and the like?
Depends on implementation, but I think that Unix tools use it libqrl for that.
Oh, that's great. Thank you.
Yeah, thank you.
Any other questions from the floor? No? If you have further questions, Vladimir will be around throughout the conference these 2 days. Please feel free to approach him if you have anything further. Thank you very much, Vladimir. Join me. Thank you, everyone.